Hi, we are the Lynx Water Consultants. We are Kevin Galindo-Marquez, William Griffin, Curran Hickey, Kevin Humphreys, and Olufunbi Jolaoso. We're here today to talk to you about the Lone Tree Creek Stream Restoration Project. Lone Tree Creek runs through Centennial Center Park in the City of Centennial, Arapahoe County, Colorado. Centennial Center Park is an award-winning facility and the first park owned by the City of Centennial. Existing conditions of the stream as it runs through the park are a concrete line trickle channel, undersized culverts upstream and downstream, underutilized park space, and general disconnection from the rest of the park. Our project objectives were to restore Lone Tree Creek to a more natural channel design, upsize both culverts to convey the 100-year event, provide connection to the regional trail system to the south, identify safety improvements for pedestrians and vehicles on Peak View, and incorporate all of the above to increase the appeal and usage of the stream. How we propose to do this is to restore Lone Tree Creek to a more natural channel design, including meanders and a pool and riffle structure, and eliminate the concrete drop structure and the concrete trickle channel. We propose more robust box culverts on both sides, as well as improved existing outfalls and rundowns. We'll provide a connection underneath Arapahoe via the culvert to the pedestrian trail system to the south, as well as a bridge over the stream to connect the east and west sides of the park. We propose a new signed crosswalk across Peak View and guardrails over the culvert, and safe spaces for interaction with the stream, including sitting areas, an interpretive play area with nature play equipment, all to make the stream a more attractive asset to the park. Our hydraulics overview shows where our proposed culverts lay, the channel as it meanders through the floodplain, riffle structures that allow us to control the grade and thereby eliminate the concrete drop structure, improved outfalls, and bank and floodplain reinforcements where our model suggested were necessary. For the park amenities and transportation features overview, we have the nature play interpretive playground area, the pedestrian bridge that connects the east and west sides of the park, sitting areas along the Bankful Channel and gravel footpaths to access them, an undisturbed wetland area, the crosswalk across Peakview Avenue, and the guardrails over the culvert on Peakview. For the channel design, we started with a reference reach study that included looking at 3 streams that were in an undisturbed state near to our project area, including Lone Tree Creek, Windmill Creek, and Cottonwood Creek. We specifically looked at sinuosity, radius of curvature, and slope to help us determine the geometry of our channel. We also considered the design guidance provided by the Mile High Flood District and the Southeast Metro Stormwater Authority. We selected a composite channel design with a main bankful channel on a gravel and cobble stream bed, and floodplain terraces comprised of natural grasses. Here you can see our proposed channel alignments for both the bankful channel and the floodplain, as well as the 100-year floodplain delineation and the 100-year floodplain isometric.
The culverts that are currently being utilized on Lone Tree Creek at Arapahoe Road and Peakview are undersized and will overtop when faced with substantial flows. The goal for this project is to create a channel that will safely convey a 100-year storm event. To do so, the size of the culverts will need to be increased. The Arapahoe culvert will also act as a trail connection to an existing network of trails located south of Arapahoe Road. Here you can see an overall view of the site with the proposed channel and culverts. Peakview is located on the top and Arapahoe is located on the bottom. The expected flows during a 100-year storm event are about 2,520 cubic feet per second. And just to put that into perspective, that flow would fill an Olympic-sized swimming pool every 36 seconds. Here you can see the existing culvert at Peakview and our plans for a replacement. The single 8-foot by 13-foot box culvert will be replaced with a dual 8-foot by 3-inch, 8-foot 3-inch by 14-foot 6-inch box culverts. These are the flows calculated for our design using a flow modeling program called HECRAD. You can see that during a 100-year event, the water will be above the top of the culvert. The flow will remain inside the channel and will not overflow onto the street. We chose a smaller size to keep the cost down. Here you can see the existing culvert at Arapahoe and our proposal for a replacement. We're proposing to replace the existing 10-foot by 14-foot culvert with dual 10-foot by 20-foot box culverts and a 10-foot by 8-foot overflow culvert, which will act as a trail connection. We designed it this way so that the trail connection will not be flooded by a 50-year storm event. Here you can see the flow through the culverts during the 50 and 100-year storm events. The culverts will safely convey the flows, and the trail connection will not be flooded unless a 100-year storm event occurs.
There's currently 2 pipe systems that convey stormwater runoff from a neighboring parking lot into our channel. The images show both of the outlets. The one on the right is a 24-inch diameter reinforced concrete pipe, and the one on the left is a 18-inch diameter concrete pipe. They both have routed boulders as their rundowns, and something that we noticed from the site is they lack maintenance, and there's a lot of trash and debris accumulated in these outlets. So for our design proposition, we're maintaining both pipe systems, and simply that's just to save time and cost. Essentially, what we're going to do is relocate the 18-inch diameter outfall, and we're going to be shortening that by a couple feet because the current outlet sits where the new channel is going to run through. We have to, or the outlets are going to sit perpendicular to the intersection of the channel to avoid any obstruction. And we plan on keeping both outlets as well with the flared end sections that they hold. And for our design, we're proposing to use a different product rather than the grouted boulders, and it's called Fleximat. Picture on the right is the Fleximat product. Once it's installed, it's essentially concrete blocks, and they're put together through special fibers. And those fibers, they have varying. It depends on the substance and what kind of soil is going to be getting placed on, but it's really well with sitting humidity. And the image on the middle is a simple plan design of where the Fleximat rundowns will sit on the pink section. Essentially, it's about 1,500 square feet in total. Something to keep in mind is the Fleximat nearest peak view, the 820 square feet rundown. There's 2 trees that sit right at the end of that, and we plan on keeping those incorporated within the channel. And so running the Fleximat within those might be a challenge. The image on the left is just a basic top view, end view, and a section view of the 18-inch diameter pipe that we're going to be relocating.
The pedestrian bridge was designed to accommodate standard pedestrian loads as well as service vehicles for the park district. It'll be made of steel and will span 30.5 feet along with concrete abutments and connected shear walls to provide foundational support for the bridge. The bridge was also designed to be ADA or Americans with Disabilities Act compliant, and to that end, it has 42-inch high rails and toe kicks as well as conforming to all of the requirements for ADA slopes. It'll also be designed to accommodate 50 and 100-year design storms where the water will actually rise above the level of the bridge. Landscape features include local flora and riparian ecosystems, meaning that these educational features will discuss the river and local plant life. An interpretive or nature play area will also be included, as you can see in the bottom right-hand corner. And gravel footpaths and a pedestrian bridge will also be utilized to give pedestrians accessibility to these areas.
After the installation of culverts on Peakview, culvert guardrails should be implemented for pedestrian and motorist safety. We are recommending a steel Midwest guardrail system, and it should be anchored along the concrete culvert head wall according to CDOT specifications. The objective of this trail connection is to safely design a connection across Peakview from south to north. The picture on the left shows the current condition of our road. In order to tackle the problem, we refer to design specifications from the Manual of Uniform Traffic Control Devices. The design solution suggests that we incorporate a continental crosswalk with a yield line that has 20-foot buffer between pedestrian and motorist, and also a yield signpost as well. The top left picture shows the existing condition of our design area. We are recommending an interpretive park with a nature play concept. According to researchers, there are many benefits associated with this type of park, and it is a growing trend. Benefits like financial, which includes increased property value, and educational benefits because spending time outdoors in nature can improve children's attention span and academic performances. Health benefits because time spent in nature is directly correlated with improved mental and physical health. Environmental benefits because the materials used are natural and biodegradable. The nature play theme, we are recommending it should be a landmark acknowledgement to the indigenous people. According to the Native Land Map tool, predominantly Cheyenne and Arapaho people are the original inhabitants of this area. We strongly recommend working closely with these communities in designing a landmark acknowledgement feature and public art in the Arapaho Trail Connection culvert.
This right here is just a brief overview of our construction sequence, not including the pre-construction or project closeout. For sequence, we essentially want to start from left to right here. We want to start with the channel, which is the biggest project, which is the biggest part of the project, and then we'll move on to the outfalls, which interconnect with the channel. From there, we'll move on to the Peak View Culvert, and which is the smaller one of the two, and then we'll move over to the Peak View connection, which is right nearby, and then we'll end up with the Arapaho Culvert, which is the bigger of the two culverts, and the pedestrian bridge.
There are some existing utilities within the project area. There's a sanitary sewer for which we are proposing a new alignment to remove it from the floodplain. There's also a gas line that will require further study to determine impact. Further study will be required to determine the state of these existing utilities, whether or not they're still in use, and what the potential impact might be.
The grading, erosion, and sediment control plan is dictated by SEMSLA and identifies how the construction process will affect the sedimentation of water within the channel. In order to prevent against that, the top center photo identifies the various mechanisms we'll be using in order to mitigate any sort of sedimentation getting into the area. And the bottom left side photo is a contour drawing of our proposed panel design. This will also demonstrate the slopes that we'll be able to install these various mechanisms on in order to prevent sedimentation in the area, and ultimately the goal will be to get no sedimentation at all into the water system.
Here we have a basic overview of our cost estimates. Essentially, we're estimating that the total project cost is going to be around $2.5 million. Our biggest costs are going to be the culverts. That includes the removal and installation of both of them, and the channel improvements, which is most of the project. And included with that, we have a 30% contingency clause. This includes the labor costs and perhaps any overhead that we might encounter. And that'll be all. Thank you guys for showing up.